Good morning, ladies and gentlemen, and thank you for joining us at our SAIEE corporate partner ROSATOM's webinar. Today, we'll be discussing nuclear small modular reactors and floating power stations, an African perspective. Before we start, a few webinar considerations. Attendees are reminded to ensure the volume is turned up on their device. Ensure you have a stable internet connection. This will ensure the streaming and audio will run smoothly. Attendees can ask questions via the questions panel located within the GoToWebinar control panel. By default, the control panel is located on the right-hand side of your screen. The chat function is reserved for webinar organizers and panelists to communicate with attendees. Attendees will not be able to chat with each other, however, are encouraged to ask questions. A recording of this webinar will be made available on the SAIEE YouTube channel, SAIEE TV, under the Corporate Partnership playlist. This channel is updated regularly, so ensure you check back as often as possible for new uploads. Please click on the link that will appear in the chat box shortly to subscribe to our SAIEE TV channel. It's free. A certificate of attendance will be issued a few days after this webinar. I'd like to now just read you what we're going to be discussing today. Small modular reactors, SMRs, is a new approach to nuclear power that provides reliable, clean and affordable electricity. SMRs can also offer long-term opportunities for local industries. In this webinar, Ms. Elena Pashina will overview current ROSATOM activities and plans in SMRs, including the world's only floating nuclear power plant, Akademik Lomonosov, and SMR solutions that ROSATOM is ready to offer to the global market. Mr. Des Muller will share his regional expertise on why Africa is considered an ideal destination for SMRs and how economically implementing these technologies in a highly regulated environment needs to be explored. I would also just like to read you a message. Unfortunately, the CEO of ROSATOM South Africa, Mr. Ryan Collier, couldn't join us today, but I've got a message from him. On behalf of ROSATOM Africa, I would like to introduce you to ROSATOM's regional office. The Sub-Saharan African Regional Center of the State Atomic Energy Corporation, ROSATOM, was opened in early 2012 to represent the company and to promote its technology and vast offering in the region. ROSATOM has been a reliable partner to the South African nuclear sector for many years, and the corporation intends to further develop this cooperation moving forward. ROSATOM is very interested in the revitalization of the nuclear industry in the region. The company feels that it has all the necessary solutions on offer to best empower the region through sustainable and affordable energy. The company not only seeks to be a technical partner, but through understanding the needs of the market, seeks rather to offer an integrated solution which includes localization, job creation, and other socio-economic benefits. ROSATOM sees the future of Africa being built on SMRs due to the lower capital cost and flexibility. I'd like to introduce you now to our first speaker, Ms. Elena Pashina, who's the Marketing Director of ROSATOM overseas. Elena Pashina has been with ROSATOM for almost 9 years. As the Marketing Director, she's working to bring the exclusive ROSATOM integrated offer for large and small-scale nuclear power plants to the market through international marketing communications, also performing analytical energy market research, including extensive activities on SMRs. Elena is a member of the IAEA SMR Technical Working Group and World Nuclear Association SMR Task Force. I hand you over now to Elena.
Good afternoon, ladies and gentlemen. I hope you can see me and my presentation well now, and I'm honored to be speaking here today. In my presentation, I will cover the information about ROSATOM as a company, about our experience in developing and implementing SMR projects, and also about our current ongoing projects in SMR development and their implementation in the near future. Okay. I hope you can see my slides on.
Yes, all good, thank you.
Great. In my presentation, let me start with a brief overview of ROSATOM as a company. We are a corporation that unites more than 300 subsidiaries, and the corporation employs over 250,000 employees. We are indeed a huge corporation, and I'm proud to be part of it. We are Rosatom, a large utility, a leading generating company in Russia. What is more important, we are a leading nuclear vendor in the world. We do business in over 50 countries around the globe. And now, currently, we are #1 vendor by large-scale nuclear power plants units portfolio in implementation, in current implementation. We have 35 nuclear power plant units in our overseas and our international nuclear power plant portfolio. As I said, we are a leading nuclear vendor, and Rosatom core business is large-scale nuclear power plants, development, construction, operation, and whole project implementation. However, today we're speaking about SMRs, and I'm proud to say that since 1954, we as the company have been developing small reactors already. They were small reactors for marine applications. It is important that for us, SMRs are not something new. This is something that we have experience in, and now, basing on that experience, we are building innovative solutions. The designer of small reactors for marine applications within Rosatom is a subsidiary of Rosatom called Design Bureau OKBM Afrikantop. Overall, this design bureau has designed and manufactured, what is important, over 20 small reactors for civil marine applications. So we in Rosatom have experience of not only developing them, but also of real manufacturing. We have accumulated great experience of safe operation of these small reactors for marine applications, and these applications are within the unique icebreaker fleet that we operate. And all in all, we have over 400 reactor years of operation of these small marine reactors. So this means that for Rosatom, SMRs is something that we know how to do, and we are ready to develop further. Basing on this technological experience, we started looking at the market, and we understand that having the experience and the technologies that we do have, now this is a fantastic response to the market need. Basically, why the market needs SMRs? There are 3 major reasons for that, but there are many more other reasons, and I will speak about them: social economic effects and other important and related to quality of life. But these 3 are the major ones why SMR nuclear power plants are a great solution for some particular markets. Number 1 is the remote areas and different settlements and industrial facilities that do not have access to the grid. The second group is the market with grid constraints. There are some countries and some regions that are not able to accommodate a large power plant. And this is just a place where a small nuclear power plant will perfectly fit and provide low cost and reliable electricity supply. One more benefit of SMRs is that they offer the lower initial capital cost. And this might be a crucial point when making a decision about building a nuclear power plant in such a remote area. Markets with well-developed grids and developed nuclear infrastructure actually also can have SMR nuclear power plants and can successfully have them, because an SMR nuclear power plant has the possibility to replace the aging conventional fossil fuel generation, and this will be a benefit that even places with developed and centralized grids will definitely want from this energy solution. Moving on to Russia and to our first of a kind floating nuclear power plant, which was already successfully implemented. I will give you some details about this project. Basing on the vast experience of our development, design and manufacturing of SMRs for marine applications, the design bureau OKBM Africantiv has developed the reactor for floating nuclear power plant. Let's have a look at the characteristics of the project. And actually the characteristics of it define why such a floating nuclear power plant is the best power solution for the place where it is currently located. First, the Russian northern and remote regions occupy over 50% of the country, with about 20 million people living there. And these people need electricity, they need jobs, they need infrastructure, they need the development of their region. And the floating nuclear power plant was just the project to bring all these benefits to such a northern region. What is more, the northern regions of Russia are located in decentralized energy supply zones. And as I mentioned in the previous slides, such regions definitely need an SMR nuclear power plant, in this case a floating one. And this was a perfect match, I would say. In such regions, such as this northern part of Russia, and this can be any part of the world actually, northern or southern, fuel transport costs account for about 80% of the electricity price. And we understand that such dependence on fuel costs is not wanted neither by the government nor by the people. For SMRs, we don't have this dependence. These areas, such as northern regions of Russia, feature underdeveloped infrastructure, such as roads and grids, and that is why a floating nuclear power plant was a project that didn't need roads or the grid and could be implemented without all that. And the last but not least point is the environment. Northern regions of Russia needed protection and environmentally, and an SMR, a floating SMR, is a project without direct emissions and as an eco-friendly, ecologically friendly project that will definitely, as we say, make the snow whiter in those northern regions, being a brick in building the future of the net zero world. Here are the technical parameters of the floating nuclear power plant. It is equipped with 2 SMRs of KLT40S design. It's a pressurized water reactor, a very well-known technology. It can generate up to 77 megawatts of electricity, electrical capacity, and up to 300 megawatt of thermal energy. These reactors are very similar to those that are used at icebreakers, and that is why that experience helped us to successfully implement this particular power plant project. The fuel cycle is 3 years and the maintenance period is up to 10-12 years. The total lifetime of such a floating nuclear power plant is 40 years, but extension is possible, so we can speak about 60. There are many questions, incoming questions about fuel. Let me answer them now. For this particular project, there is the fuel storage on board, and there is also a refueling system. So basically, this floating nuclear power plant allows to reload itself. In our next projects, the system will be a little bit different, and I will speak about that later. Since 2019, this project was already supplying electricity to the grid of the region where it is located, and we are very proud to say that the US Power magazine named the launch of this project in 2019 one of the key 6 global energy events of the year. So we are indeed proud of this, and we think it's a door opener to the market, to the new era of SMRs. After this project was fully commissioned in May 2020, it became the most northern nuclear power plant in the world. And by the end of this year, by the end of 2021, it will be supplying heat to the districts of the city where it is located in the northern part of Russia. Today, this floating nuclear power plant provides reliable and, I would say, clean, ecologically friendly heat and power to the living areas, and it also ensures the potential for the industrial development of the region. It's not only for the quality of life, what is very important, but also for the quality of the economy of the region, for the quality of the industrial development of the region. In the future, this floating nuclear power plant will replace 2 generating plants in that region, the aging now Bilibina nuclear power plant and 1 coal-fired thermal power plant. Also a contribution to the sustainable development of the region. Let me go next and speak about how we developed that concept of the floating nuclear power plant with KLT40S reactors into a new project, which is now our flagship project, a very versatile one, a very reliable one, safe and economically viable. After we launched the floating nuclear power plant, we moved on to this SMR Rhythm series. I will give you 3 major facts about this reactor, but of course we have developed it quite extensively, and in the IAEA, in the International Atomic Energy Agency booklet, there is a special part devoted to this particular reactor. So you're welcome to go to the agency website and learn more about this reactor design. Key fact number 1 is that this Rhythm series SMR is based on time-proven, well-known PWR technology. This technology has proven its efficiency, has proven its safety, ultimate safety through all the stages of the life cycle. So we can say that this is an extremely reliable technology. Number 2 fact, which is important to remember, is that being a reliable technology, it still has the innovative features such as the integral configuration, which is good because it made possible to make the reactor smaller in terms of dimensions compared, for example, to the KLT40S. And also this integral design helps to eliminate the classic large-scale loss of coolant accident. The important fact number 3 to remember today is that this reactor, Rhythm series reactor, refers to generation 3+. This question is very often asked, and we are happy to say that this is a 3+ generation reactor with ultimate safety guaranteed. And this safety is achieved both by the inherent safety features and also by the combination of passive and active safety systems and a set of physical barriers, and ROSATOM beyond design basis accident management system, which is introduced in this design. As I mentioned, the design is very versatile, and we say that we have a whole family of Rhythm series reactors. In the slide, you can see 4 of them, and we are their parameters vary a little bit, and their applications may vary. You see there is one for the floating nuclear power plant, one for the land-based nuclear power plant, one for the icebreakers, but this is all the Rhythm series SMR, and the features such as safety and reliability are relevant to all of them. Let me dive in and speak now in more detail about the particular potential projects of land-based and floating one with this Rhythm series SMR. Let me start with the floating one. So basing on our success with the floating nuclear power plant Akademik Lomonosov with KLT-40S reactor, we started developing an optimized floating nuclear power plant with ROSATOM series integral reactor, SMR. Currently this project is expected to have 2 SMRs, each are 50 megawatt, and compared with Akademik Lomonosov floating nuclear power plant, it will be more efficient. 2 reactors of 50 megawatt each give us 100 megawatt of electrical capacity. The fuel cycle will also increase from 3 years, which I mentioned earlier, to 10 years in this optimized project, and the life cycle, the lifetime of the project will be extended from 40 years to 60 years. Last year, 2020, we completed the conceptual design stage and we moved to the technical design stage already. Here I will briefly mention the benefits of this project. However, I spoke already about where and why such projects are a great fit to particular market niches. Here I will just name several maybe specific benefits that the project will bring to the place where it is going to be located. It will have the advantages of the nuclear generation, such as no emissions, the sustainability of supply, and the predictable electricity costs, which is important. It will also have such benefits as short period of construction works at the site, longer fuel campaign, and decommissioning at a special facility. It will be towed to a special facility for decommissioning. What makes this floating nuclear power plant with ROSATOM SMR a unique and a great project for markets is that they are built from start to finish in the shipyard. And the experience that we use for creating such projects is the same that we already use for the icebreakers. So we know how to do it. And the main idea that we follow with this project, the philosophy of this project, is that we try to ease the burden on the host country. So everything is made in the shipyard, and everything that we can support the host country, we will do that in terms of operation, maintenance of the plant, HRD, human resources development, and these floating nuclear power plants can also be transported to other sites. So this is a flexible, indeed flexible solution, and the burden on the host country is, I would not say nil, but we're trying to minimize it. Now let us move on to the land-based SMR nuclear power plant with the same design of the reactor, ROSATOM series design. This nuclear power plant, speaking about the one with 2 SMRs, but you can see that with the floating we had 2 SMRs 50 megawatt each. Here we have 52 megawatt each. So in total, this land-based nuclear power plant with SMRs will be 110 megawatt electric. It is important to say that it will have the modular design, because SMRs are small modular reactors. So with the modular design, we will be able to increase the capacity to meet the growing demand if it is growing. The technical parameters of the project are presented in the slide. Refueling cycle is 5 to 6 years, construction period 3-4 years. In ROSATOM, we follow the philosophy that we speak to the international partners only about the projects that are referenced in our country. So I already spoke about the floating nuclear power plant in Russia, and now we are getting ready for the first of a kind land-based SMR nuclear power plant in Russia. We plan to get the site license by 2023 and the license for construction by 2024. And during that year, we are going to start the construction, and by 2028, we plan to commission this SMR nuclear power plant in Russia. And I'm glad to speak here about even more detailed facts of the first-of-a-kind project of the SMR nuclear power plant in Russia. In December last year, ROSATOM and the Republic of Yakutia in Russia signed an agreement for the first-of-a-kind SMR nuclear power plant construction in the northeastern part of the country. And under that agreement, the Republic of Yakutia confirms the offtake of the 50 megawatt of this SMR nuclear power plant, and they also confirmed their readiness to support ROSATOM in siting of the project. In June this year, like a month ago, the team of ROSATOM conducted the public hearings in that region on the preliminary EIA and the site license materials. So we are moving towards the implementation of this project. These are the pictures of the region where the first-of-a-kind SMR nuclear power plant in Russia will be located. And I think it is important to know the characteristics of this region, because they clearly explain why an SMR nuclear power plant is the solution, is the great solution for this region. This is a very remote area with an isolated electrical grid. There are about 600 people living there, and the potential benefits that the project will bring to that region are fantastic. Let me enumerate just some of them, and I think they are really impressive. First, the construction of this SMR nuclear power plant will nearly halve the costs of electric power in this region. This is extremely important for the people living there and for the development of the whole quality of life there, making that region really attractive. The second, the SMR project will bring clean and sustainable electricity and heat supply. This is the northeastern region, and heat supply is important for them. Now, this region is mainly supplied with electricity by diesel generators, and the heat is supplied by coal-fired stations. And we all understand that this current electricity and heat supply is a source of considerable harmful emissions. And for the purposes of bringing the ecological solutions, SMR nuclear power plant is just a project, just the perfect project. What is more, these diesel generators now that supply electricity to the region, they depend on the oil refinery in Yakutsk, and the fuel is supplied via the sea route from Murmansk. So the dependency on fuel is really high, and you can imagine that at some point people there might be left without electricity and heat. And if this happens in winter time, this could be a tragedy for them. With the SMR nuclear power plant, they receive uninterrupted supply of electricity and heat, and the security of supply is guaranteed. So the region really comes to the good and next stage of their growth economically and in terms of the quality of life. This project will bring them the independence, the energy independence, and I'm sure that this will be the groundwork for the industrial development of the region too. Speaking about the quality of life, I can't but mention that the project will create jobs, and we can speak about 800 new jobs, which will be created during the process of this SMR nuclear power plant construction, and also the implementation of a mining project in that region. So the boost in job creation is obvious and is a great benefit for the region. I hope you enjoyed this fantastic news about this our progress with the SMR the land-based SMR nuclear power plant, and I would like to stop here and just enumerate the key takeaways from what I've been talking about today. And I hope that I will leave you with the thought that ROSATOM has great experience in developing SMRs, because we have the experience with the marine SMRs, we have the icebreaker fleet, we have the successfully implemented floating nuclear power plant commissioned in May 2020. We have the already developing rhythm series SMR solution, which already has been actually manufactured for the icebreakers, and now we are developing rhythm series for the floating and land-based nuclear power plants. We are working on the reference for this nuclear power plant in Russia, and we are deliberately doing that to offer the market the reference solutions, the ones that we are sure of and sure in, and we do believe that for the international market and for the African region, such solutions can be definitely a boost in the economic development, in the industrial development, in creating jobs, in ensuring the quality of life, and in bringing the region to the new sustainable period of development. And I need to say that such a project is never a project of one country. Developing an SMR nuclear power plant is a project of a regional meaning, and maybe even on a global meaning. And I do believe that these projects will be implemented more and more globally, and Rosatom as the vendor is ready to be a great partner of choice for our international partners. Thank you, and I'll be happy to answer your questions today, and obviously via emails. Feel free to contact, and thank you, the organizers. Thank you.
Thank you, Elena. Thank you very much for sharing with us that very informative presentation. I'd like to now introduce our second speaker, Mr. Des Muller. He's the spokesperson for SA Nuclear Build Platform. Des Muller is the Managing Director for the New Energy Developments, a consultancy structured around developing and industrializing a balanced and sustainable energy portfolio for Southern Africa. He is a power generation process engineer with over 35 years of hands-on experience in the development and construction of thermal, renewable, and nuclear energy projects for utility and IPP operations. He is committed to positioning, mentoring, and qualifying our local industry for the critical skills required by modern safety class energy systems within the context of our socio-economic development programs and just getting our industry back to work. He is also the spokesperson for the South African Nuclear Build Platform, industry-based advocacy, communications, and campaigning vehicle for the SA Nuclear Build Program. I'll now hand you over to Des.
Thank you, Minx. Can you see my screen?
Yes, we can. Thank you.
Thank you very much. Thanks very much for the invitation to join this webinar. And I'm going to be talking a little bit closer to home. And by closer to home, I'm meaning South Africa and the rest of Africa as well, where nuclear projects do happen in any of these countries. One of the major concerns is how do we participate as a local industry in these projects? And if one is prepared well enough in advance, there can be some meaningful participation from the local industry, which helps with the socio-economic development of these countries. I just want to talk a little bit about the South African Nuclear Build Platform. The South African Nuclear Build Platform was established to orientate and align our local industry to a nuclear build program and raise our public's awareness and acceptance of nuclear energy. Now, the reason why we did this, South Africa, a lot of you may know about, for quite some time we've been developing a 9.6 gigawatt nuclear build program. Understandably, it was the large-scale reactors. This was really before SMRs were in the picture. But that program would have resulted in a 300 billion rand spend in our local industry over a period of 15 years. And it was set aside at a time when our industries were starting to collapse a bit. Some were there already in business rescue. And unfortunately, we've lost a lot of those industries today. And we need to now rebuild that program. And hence we sat with the situation, and nobody really from the industry actually approached government and said, look, let's get our issues aside, let's get this program back to the program, and let's get the build happening, because industry needs a program like this. So what we've decided to do was really get industry united, inform industry on the benefits of nuclear energy for South Africa, and get the industry to pledge its support for this program. And we are now in a program at the moment here in South Africa, and it's time that the industry does stand up and shows its support for the program to government. The objective that we want is a fully compliant and approved nuclear procurement program in the hands of a preferred nuclear vendor or vendors, because we are looking at maybe large scale, we're looking at SMRs, we're also looking at a research reactor possibly going in the mix. And these vendors see value in engaging a well-aligned local supply chain. We want to make sure that our supply chain is ready, pre-qualified to basically add value to the nuclear vendors' localization efforts. Because a lot of these vendors, all of these vendors are going to be expected to, put in a certain amount of localization for the program or the project itself, and that will really be the responsibility of those that are got shortlisted or the preferred bidder. It's unthinkable to have 10 different nuclear vendors coming to the local industry to localize its offer. So we'll probably see it in the closing stages of the procurement process, where the local industry needs to get involved, but it needs to be prepared and ready for that. And that's really the purpose of the platform. Just looking at potential opportunities in the South African nuclear industry, we currently have the Koeberg life extension projects on the left, the Koeberg spent fuel management and interim storage facilities. These are starting as well. Going back to the Koeberg life extension projects, these are projects that are going to be upgrading Koeberg between now and 2024 to make sure that it gets approved to go ahead and continue operating till 2045. So that's what the Koeberg is busy with at the moment. Looking potentially into the future, up until really 2030 and beyond, we're looking at a large-scale reactor program. There's a potential for something like that on both the Koeberg and the Taspin sites, a multi-purpose reactor at Nexa, and that's to replace the existing Safari reactor, which was basically put into commission in 1965. So it's been around for a while. It's been producing world-class medical isotopes for the global industry, and it needs to be replaced by something newer. And then, of course, the subject of today is the small modular reactor program, which we're currently looking at. Our real interest is to support the industry for all these opportunities, to make sure that the industry is properly prepared and can optimize the local participation in these opportunities. The local industry's capacity will be key to our success. If we are not ready, we will probably not realize the opportunities that I spoke about earlier on. And of course, the South African government support will be a catalyst for localization. As we're seeing in the UK, for example, the UK government has done a splendid job at industrializing the current nuclear build, and I think they've even achieved way above 50% on the first 2 units, and certainly looking at raising it on the second 2 units as well. So good collaboration between government and the private sector is enabling local content to be maximized on projects like this. There are various types of SMRs. Elena has basically shared some of the SMRs that ROSATOM have got. There are many small modular reactor developers in the global markets. I think some of you have looked at them, and the more advanced developments could pre-qualify for South Africa. If South Africa puts out a RFP in the next coming year, I'm sure there are going to be a couple of the SMR developers that are properly prepared and ready to meet the delivery timelines of the South African inquiry. These large-scale reactors are properly ready and prepared. They've gone through their first of a kind, and they've built a lot of reactors and connected them to grid, and they're performing. So they're basically ready. The SMRs will need to kind of keep an eye on this and get properly prepared and ready for the procurement program here in South Africa. The established nuclear vendors have been joined by new entrants from the SMR industry. It's opened up tremendous amount of options. We normally would talk to 4 nuclear vendors or 5 nuclear vendors maximum. Today we're going to have to look at maybe 20 or 30 of them, and maybe single them down to, you know, maybe half a dozen. But it does give a lot of options. It does give a lot of choices for the procurement process. There's a wide range of land-based SMR designs. The processes are completely different. There are some from the original PWR process, which is really taken from the large-scale reactors and downsized, but a tremendous amount of design changes have gone in to the new SMRs with molten salt reactors, helium heat reactors, high temperature reactors, and so forth. So we've got so many choices. I don't know how a utility or a client would choose the technology he wants. Some technologies are better for providing heat. Hydrogen is now becoming an option to look at as well. So some technologies might be more suited for hydrogen. And of course, while producing those byproducts, produce electricity as well. So there's a lot of choices. One needs to be obviously educated on what the options are and what is the right SMR for my needs. All right, so SMRs are less constrained on location and can be distributed closer to the load centers. This helps to reduce the transmission losses, and it means that you can really build them anywhere, you know. What we are seeing is what Elena is basically talking about, is the floating SMRs creates so much flexibility. You know, land-based SMRs can be built practically anywhere. I think you can probably build an SMR on the moon if you want to. But the flexibility of land-based SMRs has also been improved with the floating SMRs, which we spoke about earlier in the presentation. There's also an opportunity in South Africa where embedded generation has been raised to 100 megawatts. This could fit within some of the sizes of the various SMRs that are out there. We could basically start looking at the viability or the feasibility of bringing SMRs into the embedded generation for big intensive energy users like the mining houses and the likes of the Sasol's and so forth. You know, the big steel smelters and so forth. The big energy users can certainly consider something like this. But that is a little bit down in the future. South Africa is experienced in SMR developments. We started really in with one of the pioneers back in the 2000s, where we looked at developing the PBMR technology, the pebble bed modular reactor technology, and we progressed that until 2010. and when the program was put aside. And I think then the rest of the world started, getting their programs going, So although we were, ahead of the curve back then, we certainly behind the curve today, and we've got a lot of catching up to do. But fortunately, we can see the developments, the successful actions, the successful technologies that have been developed in the global markets. And I believe that South Africa will play a significant role in both the SMR rollout in South Africa as well as in the rest of Africa. So looking at an African perspective on SMRs, a little bit about Africa itself. It consists of 55 countries with almost 800 languages and dialects. So we're very much out of communication. In South Africa, we have 11 languages and things like that. And I try my best to try and communicate some of the languages. I'm terrible at it, but it is so fascinating to hear the different cultures and experience of different cultures and the languages in Africa. And that's important that we do get to understand it and know it better. Unfortunately, 50% of Africa has no access to electricity, despite its abundant natural energy resources. We've got everything. We can produce power like you cannot believe. Unfortunately, we're exporting a lot of those natural resources and not using them for our own needs. So we need to start changing that and turn those natural resources into energy resources for us. African countries generally have low capacity decentralized grids. So a gigawatt grid or a 500 megawatt grid, 300 megawatt grid, those are typically common sizes in the rest of Africa. It's only South Africa that sits with a 40 gigawatt grid itself, which can accommodate large scale reactors as well as SMRs as well. These countries need to start getting reliable energy to start building these economies up, getting access to energy will certainly make a big difference and kickstart a lot of the economies that we're seeing in Africa's. Sometimes it could be a big mine. Mines take 20, 30, 40, 50 gigawatts at a time, even up to 100 gigawatts of power at a time. A single client like that could be, great or perfect for a distributed grid. And then obviously you supply the mine with power, and then also the community that evolves around that to work on the mine. When you look again, you've snapped up all the capacity on an SMR, you're going to have to add another one, which is quite suitable for this type of technology. Although Africa has lots of uranium, only South Africa has an operating nuclear power plant. Although Egypt is close in the hills, and I think that ROSATOM's work there as well is getting Egypt on the map, on the nuclear map in Africa. A concern that I've always had is the nuclear regulatory, legislative, and licensing processes can be prohibitive for a low capacity nuclear power plant, especially in a new entrant or a newcomer country. So countries that don't have nuclear power, and the majority of the countries are there, some of them are managing uranium, so they have a regulator and things like that, and so forth. But a lot of them are looking at nuclear power and looking at SMRs, and ROSATOM has done a fantastic job in Africa. I'm kind of tracking with some of their work that they're doing, and as you heard, the CEO is sitting in Nigeria at the moment. Nigeria has been talking to the media about its aspirations for nuclear energy. So it's great that Africa is starting to look at nuclear energy, but we need to understand the cost of getting prepared. going through the various processes to establish a nuclear regulatory environment in your country, and the costs of putting in the regulatory requirements, the legislation, and the licensing processes to license and operate and so forth. We need to start understanding how that all works. Is it going to be a quasi-IPP or PPP based package where we can participate with the local governments or the local utilities in a special purpose vehicle? How do we do that? How do we license it without putting too much costs on top of a small capacity plant? And which really says that maybe the economies of scale are for a gigawatt up. And this can certainly be accommodated by the Southern African or the African power pools. So all the various regions, which you can see on the right-hand side, have been split up into different regions. There's 5 different regions in Africa, and each one of them have a power pool which interconnects all the various countries. And some of them are also connected to each other. And I think the Southern African power pool and East African power pool is already connected, So maybe one can strategically place nuclear power plants on the power pool and then put an orders of magnitude plant there, realize or get the benefits of all the preparation, licensing, and regulatory costs, and put something substantial in there and supply the rest of the country or the region as well. So that could be a solution going forward on how to tackle bringing nuclear into Africa as well. But yeah, as I said earlier on, there could be a big intensive energy user sitting in the middle of nowhere that needs 100 megawatts, and that would be a fantastic opportunity to work with. Something that I've always looked at is we are in the process of decommissioning a lot of power stations in South Africa, the coal-fired stations, and there's been a couple of discussions amongst SMRs saying, well, can we use these sites for replacing these coal-fired plants with SMRs? It is certainly a great opportunity. The SMRs have a smaller safety zone because of the higher safety systems. They don't need a massive safety zone. So coal-fired plants are on big properties, have security fences around it, have water supplies, and they've got a fantastic grid connection as well, a large grid connection, anywhere in 1 gigawatt to 2 gigawatts. We're looking at grid connections over here. So these are fantastic opportunities once these plants have been decommissioned and stripped to look at putting up SMRs on these sites. What is also very key is the communities have developed around these plants over the last 50 years. Villages are there. There's a lot of highly skilled work and labor that really has been working on operating coal-fired plants. They can certainly be upskilled for a nuclear plant like this. We're looking at Industry 4.0 technology in the nuclear industry. It's a fantastic opportunity to upskill these people, bring in the youth, and actually, instead of turning these villages into ghost towns, we can turn them into advanced energy hubs. And I think that'll be a fantastic social economic development program, which is worth looking at, both from a nuclear vendor side as well as our country side. So what are the benefits for Africa? Nuclear energy delivers exactly what Africa needs. We need energy security. We need affordable energy. We need socio-economic development, jobs. Elena stressed it a couple of times, is job creation. And we also need environmental sustainability. Energy security, I think South Africans have really realized the importance of energy security. And that is with the load shedding that we've experienced since 2007, we haven't been able to solve it. And honestly, when you start breaking your baseload foundation, like we did in 2007, it's very difficult to put it together and repair it, unless one does something, substantial. And if you want to look at environmental sustainability at the same time, the only way you can fix that is with big baseload nuclear energy or large-scale hydro plants, which does exist in Africa, but unfortunately not much here in South Africa. As I said earlier on, South Africa has the capacity to establish an SMR manufacturing hub for African exports. This is something that we're thinking about from our previous experience and the capabilities that we have in South Africa at the moment. We can certainly establish a manufacturing hub here with a nuclear vendor. I think it's a great opportunity for the industry to start looking at. Of course, when we mobilize these projects into Africa, there is a tremendous amount of scope for the local industry in those countries. And those local skills and companies and capacities and capabilities can be upskilled to the nuclear industry standards quite quickly. It needs a little bit of time, but it can be done. We're doing it here in South Africa at the moment, and getting organizations ready and prepared for the Kuiberg life extension projects as well. And those are to level 1 safety classifications, the highest safety class requirement in the nuclear industry, and we've achieved that with local companies. Now, I said really, where African countries where SMRs are going to be built can qualify and participate in all the legislative, the financial, the regulatory, the industrial supply chain, and the O&M opportunities over the long term. When you start looking at a cradle-to-grave program for a nuclear project, you're looking at 100 years for a large-scale reactor. SMRs might be a little bit shorter, but the life expectancy of these plants is 100 years. You're going to build them over 10 years. You're going to operate them for 70 to 80 years, and then you're going to decommission them. That's a 100-year program, and that's 100 years opportunities. People say, yeah, but nuclear takes so long to build, and it takes 10 years to build. So what? It provides 10 years of jobs. Now, I've seen and I've worked in all the different type of technologies. People that we struggle to employ and get going on projects, and the project goes quickly and we can build a wind farm out there. When I look again, these guys are coming to say goodbye and thanks very much for the job opportunity, and the job's done. It's quick, but it doesn't really provide long-term opportunities, and this is something that Africa needs. It's something that Africa needs to focus on. Reliable, clean, and affordable electricity will transform Africa's economy. It will definitely make a difference. It will change your education systems. It will also help gain access to export industries. We're starting to see Europe, for example, are starting to say, well, before we import projects, we want to see your CO2 footprint, or before we import components from the world, we have our own standards. Why are we importing from countries that don't meet our standards? So we're starting to see a lot of export opportunities being blocked off because of the CO2 emissions requirements. And I think that's really being developed in the US as well as in Europe as well. And it's something that we need to take cognizance of. South Africa, for example, is one of the highest emitters in the world with regards to electricity on that side, because of our high dependency on coal. In also these technologies, we have desalination, which can be provided by SMRs. I think it's a fantastic device for that. There's a tremendous amount of heat for desalination. And the new buzzword in the industry is green hydrogen. And this is another opportunity to produce green hydrogen for other energy industries that are basically starting to evolve globally, both here in Africa as well as for export markets as well. So there are many potentials for the industry there. As I said earlier on, is that large or small modular reactor nuclear power plants can be strategically placed in the regional power pools and can power all the countries in that region while balancing intermittent renewables. So they can play an exceptionally valuable role, bring them into the harbors as well with the floating nuclear plants. It is a real good turnkey solution for Africa. What we are starting to see is here in South Africa, we're looking at floating LNG ships. There's a lot of controversy around it. Environmental issues are popping up. I think they're struggling to get their environmentals approved. And that's a challenge. SMRs will not have an environmental issue. It will not have a noise issue. Some of the challenges that we're seeing the LNG ships bumping into will certainly be handled by floating SMRs as well. So good luck, ROSATOM, with the development of more of those for Africa. A nuclear build provides the best capacity to raise the standards and the quality of our industry. They certainly help create top skill jobs during construction and operation. So it is there is nothing really that comes close to this on how the massive or the extent of the impact that a nuclear build has on an industry, the long-lasting jobs, the careers that it develops, the top skilled careers, high-paying careers. Nothing comes close to nuclear build. Anywhere in the world. So this is something that we need to look forward to here in South Africa, and something that we need to drive as an industry and as a public, because it not only provides energy security, it also provides the jobs and the socio-economic development that we desperately need. And then also is the environmental sustainability. And nuclear power plants are all very well known. The new stations coming online, the Gen 3 reactors, I've seen some of the numbers on the cost of electricity. It would probably be around parity, Eskom parity, or slightly above in the first 20 years of the project's operations while we pay off the capex. But straight after that, for the next 60 years, we'll probably be sitting at about 50% of the parity tariff here in Eskom. At the moment, Kuiberg supplies the cheapest electricity in South Africa at 40 cents a kilowatt hour. So there's a living example of the cost of electricity coming from nuclear. And it will continue to do so for the next 20 years during the life extension program. I think let's make Africa happen. It's very important that we use the resources that we've got. We've got great solar resources, we've got great wind resources, we've got coal, we've got hydro, we've got uranium, we're getting LNG as well, so really Africa has it all, and we could put our minds together and put our resources together, and we can develop a very balanced and sustainable energy portfolio for Africa, and something that will grow our economies and take Africa out of the poverty that is into prosperity without damaging the environment. That's important. Thank you very much. The presentation will be available for you guys to have a look at it, and you can also hook onto the platform's website as well for more information. Thank you very much.
Thank you very much, Des, for a very informative presentation. We're now going to go through the questions. Any questions that you might have, please just type them into the questions box and we'll have them answered now. First question, I believe is for Elena from Mr. Frans van Heerenen. He's asking, where and how are the spent fuels stored and for how long?
Yes, thank you. Let me give you the information on that for both the floating and the small and the land-based SMR. So with the floating one, for the existing floating nuclear power plant already operating in Russia, I showed the slide that the nuclear power plant basically can reload itself because the spent nuclear fuel storage is located within the floating nuclear power plant. That's the case for Russia. That's the case for the first of a kind floating nuclear power plant. Speaking about the next optimized projects for the floating nuclear power plant, all the activities with the spent nuclear fuel will be held at a special facility, not at the site of the floating nuclear power plant operation. So the floating nuclear power plant will be towed to a special facility, and during that period, the substitute will be provided, and the spent nuclear fuel will be treated at that particular facility. And this is meant to, as I mentioned, to lessen the burden that the host country has with the project. So the host country doesn't have to work with that on site. Speaking about the land-based SMR nuclear power plant, the process is practically the same as is globally implemented with the large nuclear power plants. There is the area where the spent nuclear fuel is stored for 3-4 years at the site, and after that it is transported in special containers to Russia for reprocessing, and is reprocessed there, and the final disposal of the spent nuclear fuel, according to the international laws, now is taking place in the country of the nuclear power plant location. But it's like a very, it's the final step of the SNF treatment. For reprocessing, it goes to Russia.
Thank you very much, Elena. Another question we have from Claire Lee. How are the SMRs financed, with private or public funding? I believe this question may be for Elena.
Okay. Thank you. For Rosatom implements projects both in, there are several contract schemes available for such large infrastructure projects, such as build, own, operate. There is one scheme. There is also the contract scheme called EPC, the one that is classical for energy projects. And Rosatom is very flexible in these business models. In build, own, operate, that the example of the build, own, operate business model, for example, is the nuclear power plant in Turkey, the Akkuyu that Rosatom is implementing currently. This is the example of the BOO. We expect that for the floating nuclear power plants, that would be, I would use the word might, that might be the more preferable options, but it will depend on our dialogue with the host country, how we decide to build this business model. The EPC is the classical business model when I don't think I need to explain here how the engineering, procurement, and construction contracts work, because this is the common business scheme for such projects. And I think for land-based SMRs, SMR nuclear power plants, this EPC model might be more acceptable. However, definitely we work with our partners. With every partner, we develop a partnership program, and we decide after the feasibility study of the project is conducted, preliminary feasibility study, we decide jointly what contract model would be best in terms of economic efficiency, in terms of the country's plans on developing the nuclear program in the country, and after the feasibility study, it is decided how the business model will be structured.
Thank you, Elena.
Just
a question.
I'd like to add a point here, just on the financing of these things. Typically, the countries of origin where the technology comes from provides export credit financing, and that is very much at low rates. So a lot of guys doing financial modeling on the financing of, say, for example, renewables. They try and extrapolate that into nuclear, and nuclear doesn't work, so the models don't work. But you know, the export credit agency funding, it comes in typically at 3% or below at the current global markets at the moment. Another very interesting model that is developed and has been used extensively in Europe is a funding model where intensive energy users can help fund the capital of a nuclear build program. I don't know how this lends to SMRs, but certainly for large-scale reactors, which are big capital costs over quite a long period of time, the intensive energy users can help capitalize those projects in exchange for very stable, competitive, long-term offtake agreements. And that has been done currently in Finland and under the Mankala transaction, and then also in France under the Exceltium model as well. And that is, this definitely helps a lot of the intensive energy users that want to reduce their CO2 footprint, and they get a very high capacity, low emissions technology, and a very reliable technology that is there all the time, and also at a very stable price over the time. So it's not really escalating to fluctuations depending on the gas prices on the global markets, you know. So those are also options that we could look at as well for South Africa and the rest of Africa.
Thank you, Des. A question for you from Abdul Idris. He's asking, he says, I can certainly appreciate the benefits of SMRs as a modular model, but in the South African context of power shortages and existing coal stations reaching end of life, should large-scale reactors not be the ideal focus currently to address the issue?
I think we need both. Large-scale reactors are currently available today. You can price them, you can contract them, and they could start building quite soon. Small modular reactors need a little bit of time to get through the proof of concept, their demonstration plants. China has now started its first demonstration plant, which is showing that the designs that have been developed over the last decade are certainly maturing to the point where construction is starting. ROSATOM is also there, you know, as well. Small modular reactors will be available through the first of a kind stage, I think 2028, between 2028 and 2030s, and maybe a little bit beyond. We'll start seeing a lot of SMRs becoming commercially available, that you can procure them and you can actually buy them off the shelf and you can build them. They've gone through their first of a kind phase, very much like the Gen 3 reactors had to go through their first of a kind phase. So I think, you know, the large scale reactors take a little bit longer to build. Small modular reactors will start a little bit later in the program, but they are quicker to build. We could look at getting energy on the grid more or less at the same time. And if we kind of get ourselves going at a rapid rate, we could probably see first new nuclear power on the grid by around about 2030 and 2032, somewhere around there, both from large-scale reactors as well as small modular reactors.
I think I can also add something to what Mr. Muller said, if you don't mind.
Yes.
Minx? Yeah, adding to what Mr. Muller mentioned, I can say that basically for the SMR nuclear power plants, in terms of capacity, turn out to be closer to the capacity of the coal-fired plants that are reaching the end of their lifetime, because classically the coal-fired plants are 300, 400 megawatt, and when we speak about the SMR nuclear power plants, speaking about its modularity, we can say that 2 reactors give us 100 megawatt electric, 4 reactors give us 200 megawatt electric already, and 6 reactors will give us 300 megawatt. So maybe for some areas, SMR nuclear power plants might turn to be even more better suitable to substitute the coal-fired plants in terms of capacity. Another point here for the record is that SMR nuclear power plants are able to be located closer to the final consumer, be it the living area or an industrial facility. Taking into account the emergency planning zone, SMR nuclear power plants can be closer to the final consumer. So maybe for areas where coal-fired plants were supplying electricity and heat to consumers nearby, also this can be done by SMR nuclear power plants. And my third point would be that we never try to compare or to compare large-scale nuclear power plants and small-scale nuclear power plants. This is not something to consider this or that. These are the energy supply solutions for different conditions, and they are not substituting each other. They are adding up to each other in creating the energy ecosystem, the energy mix, the regional ecosystem. So for areas where large-scale nuclear power plant for several reasons cannot be fit in, and the reasons are numerous: commercial, economic, site conditions, the SMR nuclear power plant would be best. For areas where the grid, the economy, many factors allow for a large-scale nuclear power plant, this will be a solution for that area. So we suggest looking at them as different products for different niches with their special characteristics. Thank you.
Thank you very much. Another question for both of you from Mr. Ewart Sneyman. He says SMRs will need to work with renewable energy sources. These sources are not stable, and the SMRs may be required to stabilize the grid and load follow. The load will also change during the day. Is this possible?
Yeah, I mentioned in my presentation that there's various designs of SMRs on the market, and some of them are suited for baseload technology, and some of them are a lot more flexible that could do load following. All nuclear power plants today can do load following to a certain degree, even the large-scale nuclear plants. They are very good at following load, whereas previously they were more base load, very much like coal-fired stations back in the day were base load, and don't like variations. And especially SMRs, a lot of them have got some very clever designs in where they put in thermal molten salt, thermal capacity to bring in as there is a shift change on the demand on the grid. And so SMRs are very, very handy at following the intermittency of renewables. And it's something that a lot of papers have been written on, is how clean energies can work in harmony with each other. I'm not sure why there's this big scrap with each other. We don't like each other, but honestly, we can certainly work in harmony with each other and change the situation with regards to our CO2 emissions and achieve some of the goals that we promised quite a long time ago. We're certainly not even getting near there, you know. So a good combination between nuclear, hydro, renewables, and a bit of gas on the side, I think can definitely change the landscape, especially in South Africa, where we have a dominance of coal, which is getting retired at a rapid rate. And that is at an alarming rate. So you've got to wake up to a lot of solutions to basically keep the lights on in the country over the next decade. By 2030, we could be in challenging times because of the decommissioning program that we're looking at the moment. Thank you.
Thank you.
Yeah, and I would add maybe a small comment that the agency, the International Atomic Energy Agency, is currently running a CRP, a coordinated research project on the hybrid solutions where nuclear and renewables are looked at together as part of a hybrid energy system. And I know that, I mean, Rosatom and Russia is actively an active participant of the agency's activities, including this one. And we do believe that this is this hybrid system is a system that will be of interest to many host countries. This is definitely a combination that brings benefits. The nuclear power plant, the SMR nuclear power plant I was talking about today, the Rosatom SMR, envisages the possibility of a load following from 20% to 100%. So we support the importance of this question. Our reactor is in line with this topic, and we are looking forward to the results of the CRP of the agency, and we do believe that these hybrid solutions will be developing. It's a very interesting thing. Thank you.
Thank you very much. We have our next question from David Nichols. He's asking, what is the expected operating and maintenance cost expected for the optimized land-based projects?
Over to you, Elena.
Yeah, I would just say that the questions about cost, I hope it will be professional, most professional from my side to say that giving the generic estimates of costs will be misleading now. And what we do is that we conduct with our partners, we conduct the preliminary feasibility studies. It's even not a full feasibility yet, but the preliminary feasibility where we have the financial economic model, which already takes into account the input data from the potential site, at least a potential site, because the characteristics of the site and the characteristics and the figures of a particular country, the cost of labor, the cost of utilities can significantly influence that figure, and giving a generic figure now would be misleading. But a preliminary feasibility study, which can be conducted with any partner that wishes to do so with us, will answer that question. I think from my side, that's it. And Mr. Muller will give a maybe more detailed answer on the O&M costs, if any.
Yeah, look, for SMRs, we're obviously looking at it very carefully. We've got a tremendous amount of data on the existing large-scale reactors, and we're expecting to see SMRs coming in at similar numbers, if not cheaper as well. You know, especially as the economies of scale goes up, where you build 4 reactors in one containment building or one location. It definitely, the economies of scale drops off quite nicely, not only on the construction costs, but also on the O&M costs, and then that reflects very much on the electricity costs. So I think let's have a look at, see what those numbers come out like. I've seen a couple of numbers from various nuclear vendors from the SMR stable. Some of them are kind of daring to make a number out there, and they're looking very attractive and certainly very feasible and very viable for Africa to consider as well, knowing very much what the African energy costs are out there, they could certainly make a significant difference.
Thank you. We have a next question from Mr. Nicholas Pierre Ferrier. He's asking, how flexible is the generation? Can it accommodate easily lot of stop-starts, variation in charge or load? We are under the impression that conventional nuclear is mainly baseload power without interruption. Does SMR bring more flexibility?
Elena, you can start on that.
Yeah, I would just maybe have to reinforce what I mentioned earlier, that the SMR nuclear power plant is designed to be flexible. Load following is there. It can go down to 20% and then up to 100%. So I would say, yes, it is flexible.
Just a point on flexibility. A lot of plants, as we were saying, in our presentations, is that we're not only looking at generating power today. These plants, especially with SMRs, the new generation SMRs, can be adapted towards creating desalination, creating green hydrogen, creating process heat. There's a variety of options. So if there is a drop-off on electricity demand, you can switch that energy over to desalination or process heat, or even create a bunch of green hydrogen, which can transport and store or use again, if you have a peak demand, So there's a tremendous amount of flexibility in these technologies today. It's not only about electricity like it was in the past. Today, they can do many things.
And I can maybe add here that they can do many things, and ROSATOM, since I'm representing the company today, we have solutions for all that Mr. Muller has just mentioned: desalination, hydrogen production, heat, and hydrogen production in particular has been a topic of discussions recently, and electrolysis with the use of electricity from the nuclear power plant will ensure that this hydrogen is low carbon and can be called green. So we have solutions for all those additional parts of this energy hub, I would say. So yes, it's no more about just electricity, it's about the ecosystem, and this is all what ROSATOM is developing.
Excellent, thank you, Elena. Another question, this is aimed at Des to answer, from Mr. Sakele Madela. He's asking, why do nuclear vendor companies shy away from sponsoring lobby groups, organizations that promote nuclear? Or the vendor companies prefer to do it secretly and they don't do it at all? Your take on that?
Yeah, I think that might be a South African thing, where we've had a history of start-stops on nuclear procurement and things like that. And I think the nuclear vendors are trying to obviously give the government space to make its decisions. And in South Africa today, we are in a procurement process where the DMRE has submitted a Section 34 determination to procure 2.5 gigawatts of nuclear energy for South Africa, and has now provided that to NERSA. NERSA is now basically looking at it, and it will then make its decision. And I think this is the point in time where nuclear vendors need to kind of step back, let South Africa make its own decision. And you would tend to find that, one could easily get into a conflict of interests and things like that, disrupt the process and things. So I think, the nuclear vendors are kind of distancing themselves just to be sure that we are following the right protocols, not interfering with the process or disrupting the process, and making sure that a compliant nuclear procurement program happens, which is really what we on the South African Nuclear Platform want. We want a very compliant process in the hands of a very well selected nuclear vendor that is right for our energy needs for South Africa. And I think the rest of Africa wants that as well. So I can understand the distancing or portioning.
Thank you, Des. Another question here from Mr. Ewart Sneyman asking, SMRs will only make financial sense if constructed in large quantities. What number of SMRs does ROSATOM predict will be constructed within the next 10 to 20 years? Elena?
Yeah, so currently, if we speak, I think this question is about the global construction, not about ROSATOM in particular, but about the global SMR market. We see currently that actually under development, there are over 50 designs of SMRs globally. So definitely ROSATOM being one of the leading vendors, but we see that many other vendors are doing that. It means that the technology developers are pretty much sure that this technology will be desired on the market. Now moving on to how we see the market development. I mentioned the characteristics of the sites that will be just the sites for such capacity and such type of a project. And I do believe that these regions cannot be attributed to any particular, say, part of the world. Such type of areas can be found in any continents. We have these remote regions in the northern part of Russia, and the same remote type of remote regions can be found in Latin Americas, or again in Africa, or in Southeast Asia. So this type of a site, which is just the one that needs an SMR, is a typical remote or a typical area which can be found anywhere globally. So we expect that the market will be really first multi-international. It will be definitely global, and second, it will be big. We do understand that SMRs are becoming parts of the integrated ecosystems, as we spoke about their joint work with renewables, with hydrogen. This will be the new era of new approaches to secure energy supplies. So we see that the market will be quite huge, and that is why we are developing both the floating and the land-based, because we understand that areas that need smaller nuclear capacity sometimes might be located in the areas without road infrastructures or rail infrastructure, and a floating nuclear power plant will be fitting that particular site. So since we're developing this versatile number of applications for SMRs, we're strong believers that the market will be huge. But I wanted to say in any type of a country with developed grids that needs to supply electricity to industrial facilities, countries with underdeveloped grids that need to supply electricity, heat, and develop the remote regions, countries in the north and in the east. I won't give you the number in megawatts, but we do believe that this is the market is there, and we hear. I can't disclose the dialogues that we have with potential partners, since it's the strategy of the company. But I can assure you that we have a number of dialogues already with international partners, with countries, and during the meetings within the International Atomic Energy Agency, World Nuclear Association. The interest is huge, so we are strong believers in the market for SMRs.
Thank you very much.
I'd like to add to that. I'd just like to add to that, Minx. You know, we don't want large-scale reactors and SMRs to start competing with each other. You build a large-scale reactor, takes you 10 years, you got 1.6 gigawatts on the grid. That is equivalent to maybe 10 to 20 SMRs. How long will it take to build those SMRs and things like that? We don't want to get in that game. Large-scale nuclear build has its role to play. It has its location where it can build. There's not too many locations. It likes lots of cooling water and so forth. So it's got to be coastal. SMRs can be distributed, you know, put in closer to the load centers, reduce transmission losses. I mean, we've got so many transmission losses. We are providing power from the north of our country to the south of the country. It's like powering London from Rome, and that is unthinkable. That's South Africa. We need to start looking at just decentralizing our grid, and that's the value proposition that SMRs brings in, to try and get and compete with each other. Honestly, if somebody wants to try and create that competition, we're not interested. We have different roles to play and different value propositions for the client.
Thank you, Des. There are quite a few questions we won't be able to have time for, but I will ensure that our presenters answer your questions, and I will personally send it to each one of you that's asked a question. Our very last question for today is from Adrian Hobson, asking, how long does it take for you to see a return on investment on an SMR?
Can you repeat that, please, Mings? I don't think I heard the...
How long does it take for you to see a return on the investment on an SMR, ROI?
I don't think, thank you for this question, but I don't think this is something that I can speak about today. This is, we have a strategy. I mean, the ROSATOM definitely developed a strategy for SMRs, and several years ago, it was already maybe 5 years ago, when SMR nuclear power plants became a priority strategic area for development for ROSATOM, in terms of business development and R&D development, and at that very point, the financial models were calculated, but I don't think I'm entitled to speak about that today. However, I'm encouraging our viewers today to get in direct contact after this webinar, and we will be happy to talk by emails and arrange a call after we sign an NDA to talk about figures in detail. We will be happy to do so.
Thank you so much.
On the return on investment, nuclear energy really sits in the realm of utilities up to now. I'm not sure how the SMR program is going to roll out, if it's going to be really in the hands of IPPs. There's not too many globally that are licensed to operate a nuclear plant, unless the likes of ROSATOM becomes an IPP in collaboration with the utility. But we're still very much looking at utility scale type projects, where return on investment is not necessarily a big equation. You just really want to make sure that you're not providing a technology that is going to increase the price of electricity in the country. As I said earlier on, that nuclear energy, both large scale and SMRs, should come in at South Africa's grid parity or slightly above it during the initial phases of the plant, while we pay off the capex. But thereafter, it will be about 50% of the parity cost of grid tariffs in South Africa. And that is where you really make money for the utilities once you pay the capex off. And if you can reduce that capex, and you can reduce the time of construction to reduce the interest during construction, man, you're going to see the levelized cost of electricity drop off. And that's the game that we should be focusing on, as in the SMR space, as well as in the large scale space as well.
Thank you, Des. I can just tell our attendees, if you have any additional questions or want to get hold of Elena or Des, please email me. It's minx, M-I-N-X, @saiee.org.za, and I will make the connection between you and the presenters. I thank you very much for joining us today, and thank you to our presenters, Mr. Des Muller and Ms. Elena Pashina, all the way from Russia, for giving us a brilliant webinar today. It's also the last one in our ROSATOM series. It was great working with you. And I thank you to all the attendees for attending and your great questions, which will be answered and will be uploaded on the SAIEE website. but also the recording of this webinar will be made available on our SAIEE TV channel on YouTube. Thank you very much for joining us, and you all have a wonderful day further and stay safe. Take care.
It was a pleasure. Thank you very much.
Thank you. Goodbye.